How's it going, everyone? Welcome back to the next lecture. Today we're going to be talking about MAC addresses. And so in a previous lab, we have looked at pinging a device on a specific IP address that had a MAC address. That being said, the big difference between MAC addresses and IP addresses is that MAC addresses are going to be a unique identifier assigned to that specific interface, and it cannot be changed. Obviously, it can be spoofed and can be used for malicious intent, but that's going to be a conversation for a different day. That being said, IP addresses can be changed and are often changed by the users in order to fit specific network requirements. So the format of the MAC address, if you haven't seen, and we'll look at a couple of examples. So in the previous lecture, we had looked at a PowerFlex VFD, and it's going to be on this internal label here on the side. Again, put as close as possible to the actual Ethernet port. And then on other devices, that label is going to be in other locations. So here I have a Compact Logix PLC. As you can see, the MAC address is going to be right on the front of the device, while the Ethernet port is going to be on the bottom. So you have to spend a little bit of time to look at the various devices that are going to be on the Ethernet protocol to locate the label. So sometimes it's going to be a little bit more obvious. Sometimes, for example, on the Siemens IPC, you will have a label that's going to be on the side of the device, and that's going to specify the MAC address for the device. And so the goal of MAC addresses, right, as I've mentioned, it is a unique identifier. In the OT side is to prevent errors, right? So reasonably speaking, and I'll give an example in just a moment, it is something that you need to pay attention to primarily during the commissioning phase of your equipment. But also you need to pay attention to as you connect to those devices until they are specified and basically historized in some kind of a software and or tool. So what do I mean by that exactly? Well, let's start first with basically describing a MAC address. So you're going to have, as you've mentioned, 6 different numbers. So here is a very good example, usually separated by dots. It could be separated by semicolon. It could also be 4 basically numbers. And this is going to be a hexadecimal representation, just like you would see with IP addresses. But basically, here's an example of a MAC address. So 76.84.10.89.66.33, right? And so, like I said, there's going to be some theory as to how these are assigned. Usually the first 3 octets are going to be based on manufacturer, and the 3 last ones are going to be assigned by the manufacturer, essentially at random to some extent. Now, I don't want you to memorize. None of that truly matters when it comes to OT systems. What really matters is when you connect to the device, you need to know that you've connected to the right device, right? And so I'm just going to erase this and illustrate a very common situation in manufacturing. So what happens is you bring in a new piece of equipment, a new machine. It could be an entire line, but we'll keep things simple for now. And you have a PLC. So I've drawn this a couple of times before. So let's say this is the power supply PLC. You're going to have different I/O cards, and you're going to plug this in, for example, on the plant network. So this is going to be plant. This is going to plug in on the internal network of the machine. And so the internal network of the machine is going to have a switch, right? So multiple ports. And again, you don't need to understand how this works for now, but imagine that you have basically a splitter of a switch that's going to drive multiple devices, right? So here you're going to have VFDs, just as we've seen in the lab session. So you have multiple VFDs. Sometimes I've seen panels with hundreds of them. It could be multiple panels with a number of VFDs. And all of these VFDs will arrive usually plugged in or connected via RJ485 or a standard Ethernet cable, right? So you have multiple VFDs. you will have an HMI screen here on the machine, maybe even multiple HMIs. One is going to be directly on the panel, a few of them are going to be directly in the field to allow for controller operation. And so your task as the engineer, whether you're on the control system side or on the OT or IT side, is going to be to assign IP addresses to all of these devices. Well, the challenge, of course, and you can solve this in a couple of different ways. You come in with a laptop in person, right? Because ultimately, in these scenarios, you don't have the connectivity to the server yet, since none of the IPs have been assigned. There's, again, some nuances to that, but we'll get into that in just a moment. But you arrive with your laptop, and you're going to start by connecting to each device one by one. Well, you have two options, right? So you can connect and you can plug into the switch, and you can set the IP address of the switch followed by all of the devices that you will find using, again, various tools. You can scan the entire network. You can use a tool on the Rockwell side called BootP. You can use Connected Components Workbench for your VFDs. You can use some other tools like RSLinks, for example, for some of your HMIs. But the challenge here is as follows. The challenge is that as you connect to a system that has multiple devices, whether they have IP addresses or not, you will immediately be unable to identify which device is which, right? And so the problem then on a live system, and even in a system that you've commissioned, you can easily make the mistake of, instead of, for example, setting the IP address of this HMI, you're going to set the IP address of this PLC, you're going to set the IP address of the switch, or you're going to set an IP address of the VFD, right? So to avoid that, what you can do is you can go to the HMI physically, you can locate the MAC address, right? So again, you're going to have x.x.x. some kind of identifier 06.78.38, right? As an example. You can, usually I would take a picture of this or I would write it down in a notebook. I would go back to the station that is seeing a lot of different addresses, and I will make sure that the IP address I'm assigning to a specific device matches the MAC address specified on the device, right? The alternative, of course, is you can disconnect. So for example, if you have a VFD that's currently connected to the port of this Ethernet switch, you can simply disconnect this cable and connect directly from the VFD to your laptop, right? So just as we've done on the test bench, you can simply connect to that device to connect via CCW, and you've basically prevented the issue of assigning the wrong parameters, the wrong IP address to any other device. Now, of course, I say that a bit with a caveat, right? So in a commissioning type of an environment, you can disconnect devices and you can connect to a specific device. What happens once the system is already running, and for example, let's say you have a request, we need to add an extra HMI, right? So you're going to add an HMI, you can commission that HMI before you put it onto the switch or onto the network. But if you want to make changes to an existing set of equipment, let's say you walk up with your laptop and you plug in, and you now see a lot of different devices on that network that you're not necessarily familiar with, it is very easy to make the mistake and to connect to a different device. And in the worst case scenarios, and I've seen this happen, you would have engineers that will basically overwrite the program of a PLC. And this is a little bit harder to do, I guess, nowadays that we have a lot of different identifiers than in the past. Some of the legacy protocols like Data Highway Plus, for example, were a little bit more prone to that problem because the assignments of addresses on Data Highway Plus were a little bit more difficult to manage and weren't also tied to a specific identifier of the device. So going back to MAC addresses, right? So as I've mentioned, each device is going to have a unique MAC address. So here, our drive is going to have, for example, the last 3 octets is 76.A3.73. And so you're going to be able to write this down, and as you connect to that device, I always want you to double check that the MAC address of the device in the real world matches what you're pushing your changes to from your specific machine. As I've mentioned, this is Also a problem compounded by the fact that a lot of times you will have, for example, a server rack here, right? And I don't know how well you can see this, but maybe I'll draw it a little bit here. So you have a server that's going to connect to the plant level to that specific PLC. And not only are you going to see this architecture, you're also going to see a lot of the different architectures at the plant level. So you have multiple VLANs, you have multiple machines potentially with the same IP address. And so the only way for you to ensure that you're pushing your changes and updates to the right, not only controller, but also peripherals, is to make sure that the MAC addresses match. So hopefully that explains MAC addresses in a practical way. I don't believe it is as complicated as some of it is made out to be. If you have any questions on how you can leverage MAC addresses for your specific application, or if you have maybe more complicated scenarios, don't hesitate to reach out. We'll make sure to answer those questions.